Hello, launch fans, and welcome to today's live webcast of Rocket Lab's fourth Electron launch, the ELaNa 19 mission for NASA. We are broadcasting to you live from Launch Complex 1 on New Zealand's Mahia Peninsula and Rocket Lab Mission Control in Auckland. It is Sunday, December 16th, and we are preparing for Electron liftoff approximately 16 minutes from now. My name is Amanda Stiles, and I'm a Senior Mission Manager here at Rocket Lab. I'll be your guide through today's launch activities. You're looking at a live view of the Electron launch vehicle at Launch Complex 1. Today's mission will be Rocket Lab's third orbital mission for 2018. "13 CubeSats will be launched as part of today's mission, and many of these spacecraft are getting their ride to orbit through a NASA program called CubeSat Launch Initiative. This exciting program recognizes that CubeSats are playing an increasingly significant role in exploration, tech demonstration, research, and education. Small spacecraft like the ones launching today are opening opportunities for fast and cost-effective research and commercial applications in space. Now let's listen for the final go or no-go from Mission Control. Mission Control has given the go for flight, and our flight director has given the final go to proceed with launch, which will take place in just under 14 minutes from now. Electron is fueled and ready at Launch Complex 1 with Electron go, range go, and the weather go. We've also informally pulled the sheep and their go as well. Today's mission is called ELaNa 19. ELaNa stands for Educational Launch of Nanosatellites, and this is the 19th ELaNa mission by NASA. In addition to the mission name, Rocket Lab also names each Electron launch vehicle individually. The launch vehicle for ELaNa 19 is called This One's for Pickering, in honor of New Zealand-born scientist and former director of NASA's Jet Propulsion Lab, Sir William Pickering. For 22 years, Sir William Pickering headed up JPL and led the team that developed the first U.S. satellite, Explorer 1, which launched in 1958. Members of Sir William's family are joining us outside of Mission Control today to watch the launch. It's an honor to have them here with us today.
To all operators, my mark will be at minus 12 minutes and counting. Mark.
The next milestone to watch for is retraction of the strongback. This is the tall black structure supporting Electron. The strongback will be pulled away from the vehicle by 22 degrees to protect it from the intense heat of Electron's engines during liftoff. Once retracted, Electron will be fully supported by 4 hold-down clamps.
Top lamp open, proceeding with strong back. Retract.
Flight, this is Arif. On mission call.
Yes, sir.
Procedure.
Today's
Alpha
mission is
3900.
significant
It's
for
complete.
Rocket Lab, NASA, and the small satellite industry as a whole. It's the first time NASA CubeSats will enjoy a dedicated ride to orbit, thanks to NASA's Venture Class Launch Services Initiative, known as VCLS. NASA has provided a short video to tell us more about the VCLS program, which was put together by students from the Dave School. Enjoy.
In the beginning of the NASA space program, bigger was better. Big ideas required big rockets. These big rockets took us farther than we'd ever dreamed possible. First into orbit, and then to the moon. They've taken us to the edge of the solar system and beyond. They've given us a new perspective on the universe. And allowed us to explore distant worlds. In the beginning, big ideas required big rockets. But today, as technology continues to get smaller, size is no longer the limit. Introducing NASA's Venture Class Launch Service, a smaller class of rocket, inspiring us to think bigger, dream bigger than ever before. Venture Class. Smaller rockets designed by smaller teams. Dedicated payloads. Faster turnaround at a fraction of the cost. Launching satellites you can fit in the palm of your hand. Helping to expand the industries of science, technology, and communication. Bringing us closer together by making space more accessible than ever before. Big ideas. Bigger dreams. In a smaller package. Venture Class.
While we wait for the remainder of the count, I'll talk to you about some of the key features of the Electron vehicle itself, as well as today's mission. Electron stands at around 17 meters, or 56 feet tall, and is a two-stage orbital-class rocket fueled by liquid oxygen and highly refined kerosene. The first stage makes up approximately the lower two-thirds of the rocket. At the base of this are 9 small and mighty Rutherford engines, which are built at our Huntington Beach headquarters in California. Each engine is 3D printed and features electric pumps which remove the complexity of traditional gas turbine pumps. These 9 engines accelerate Electron through the thickest part of the atmosphere to space. From here, the first and second stages separate, and then a single vacuum-optimized Rutherford engine carries the second stage to orbit. This stage separation happens around 2.5 minutes into the flight. Then the protective fairing that safely encapsulates the payloads on ascent will open and separate from the vehicle.
Confirmed.
RCO, flight on mission core.
This is RCO, go ahead.
Switch off FTS ground power and confirm.
Stand by. FTS is down.
FSO, flight on mission core.
FSO go.
I confirm FTS is on internal power. Check tone should be continuous from now. And FSO, please enable FTS failsafe and confirm.
Copy. Failsafe up. Failsafe enabled down.
FTS, this is flight on mission core.
Go flight.
Please confirm FTS is green on internal power.
FTS is green and go for flight.
And to all operator, for now there should be no red flag on your launch commit criteria.
Inside the fairing is
FSO
Rocket Lab's
flight on mission
in-house
code.
designed and built kick stage, powered by the 3D printed
ahead.
Curie engine.
Please confirm flight
The
safety is
payloads
green.
are attached to the kick
Flight
stage, which
safety
will
is green.
separate from stage 2 at around
And
9 minutes
RCO,
into flight.
This is flight on mission
From
core.
here,
Please
the
confirm
kick
range
stage
is green
coasts for
and
about
auto
40
sequence
minutes
R
before the
is
Curie
enabled.
engine ignites and places the payloads into a 500 by 500 kilometer circular orbit at 85 degrees. At approximately 52 minutes into flight, payload deployment will begin, and then the mission will be complete. At that point, the webcast will conclude, and any further updates will be provided via our website and social media.
Avionics flight on mission core. Please disable HVBAT heaters and confirm, and also HVBAT heated fans.
Confirmed, both disabled.
And to all operators on mission core, vehicle is ready for flight.
In a few minutes, the vehicle will enter the final launch auto sequence. Once in this stage, Electron's flight computers will have taken over the vehicle. At any point until T0, our operators can call a hold and pause the
EMS,
countdown.
this is flight on
Now
mission
let's
core.
listen to the mission
Flight.
control audio and
We are
follow
go
the
for
final
auto
launch
start
sequence.
at T-minus 2 minutes.
Copy.
Avionics, this is flight on mission core.
Go flight.
Please confirm all AVBATs have been switched to internal power.
Confirmed, vehicles on internal power.
And RCO, flight on mission core. Please
Go ahead.
confirm ground power is disabled on all 3 stages.
All stage powers down.
To all operators, vehicles on internal power.
It's in locks.
ELS, flight on mission core.
Go ahead.
Please disable anti-geysering and confirm.
Disabled.
Stage 1, confirm locks is pressed.
Confirmed.
Stage 2, confirm locks is pressed.
Confirmed.
Stage 1, confirm carrier is pressed.
Confirmed.
Stage 2, confirm carrier is
Confirmed.
Engine
all stages are
pressure.
pressed.
Enabling deluge. Can confirm deluge on. Using GNC states. Rereading engines.
Ten, 9, 8, 7, 6, 5, 4, 3,
Ignition.
2.
Stage
Control confirmed.
IRP tracking downrange.
As you just saw, we've had successful liftoff of Rocket Lab's ELaNa 19 mission. This one's for Pickering. The next major milestone we're coming up to is Max Q, or maximum aerodynamic pressure. This is where the forces on the vehicle are at their greatest during launch.
is nominal.
Let's stand by for the call.
approaching maximum dynamic pressure. Max dynamic pressure. Stage 1 propulsion is nominal. Open power pack CO2 bottles.
Coming up next are a series of events that take place in quick
25 seconds
succession.
remaining.
These are MECO, or main engine cutoff, followed by stage 1 separation, stage 2 engine ignition, and then fairing jettison.
Minimizing
Let's
angle
listen
attack.
in.
Entering burnout detect mode.
Stage 1, main engine cutoff.
Staging.
And stage 2 propulsion is nominal.
Stage 2 is stable.
Fairing deploy.
And that completes MECO,
Stage
stage
two,
1
controls
separation,
normal.
second stage ignition, and fairing separation. Electron's second stage is now on its way to orbit.
Continuing to follow
We'll
nominal
listen in
track.
for the call that Electron is orbital at approximately 9 minutes into flight.
Altitude is 150 kilometers.
Our next milestone will be battery hot swap. One of the unique features of Electron is that our Rutherford engine uses electric pumps. These pumps are powered by batteries, but once these batteries run flat, they're just dead weight. To overcome this, we perform a hot swap where we switch from 2 depleted batteries to a third fully charged one. We then jettison the depleted batteries, and that mass savings allows a more efficient ride to orbit. Look out for the battery jettison occurring at around T+7 minutes.
Three kilometers per second. Four kilometers per second.
Coming up on hot swap. Swapping. Eject.
Stage 2 propulsion nominal.
We've had successful hot swap of our batteries, and Electron is performing nominally.
5 kilometers.
Just to recap, we had successful
Copy that.
ignition,
Failsafe
stage
disabled.
1 burn, and stage separation, and now we're following stage 2 as it continues to orbit. This burn will continue until around T+9 minutes, and then our kick stage will separate.
80 seconds remaining.
Copy after you saved.
$30 remaining.
We have about 30 seconds remaining in the stage 2 burn. Electron is following a good trajectory, and propulsion is nominal.
$10 seconds.
Vehicle is orbital.
Stage 2 engine shutdown.
Shut down. Transfer orbit appears nominal.
Staging.
That call confirms Stage 2 engine shutdown and kick stage separation. The kick stage is now entering a coast phase for around 40 minutes before the Curie engine will ignite
Based
to
on
circularize
final
its orbit and deploy the payloads.
We reached an apogee of
We're going to take a break
487.4
and come back in
kilometers,
approximately
period
40 minutes for the
218.09
final payload
kilometers,
deployment.
inclination 85.03
In the meantime, sit
degrees,
back, relax, and
which
enjoy
is
watching
very
Electron's
close to a
path
normal
as it
transfer
orbits the
orbit.
Earth.